Three, two, one. And we are live. Hello again. Part two of the podcast. This is episode 7 now, which is our 10 principles for DevOps part 2. So amazing stuff. We covered a lot of ground in the first episode with principles 1 to 5. So the first principle, the principle to rule them all, is principle number 1: everything is automated. So we set the goal of automating everything, and then we do as much as we can to get towards that. And then we have the 9 principles for mortal men, which are so going from that principle number 2, Git is the source of truth, or have one source of truth in the repository of your choice. Principle number 3, that we don't store sensitive information in that repository. Just don't. Right, listen to the past episode and just don't do it. There's good reasons. Principle number 4: adopt an infrastructure as code approach, and principle number 5: adopt an immutable infrastructure as code. Again, obviously, this is just running through them. Listen to the previous podcast if you haven't. If you want to go through the detail on these, there's fantastic content on there, and we'll go through that. But we find ourselves, keen and eager at the halfway point where we start to look at principle number 6, and I feel at a loss because I haven't got any jokes lined up for this bit. And principle number 6, adopt an immutable application approach, doesn't really lend itself to comedy either. So but we can dive in from there, and I'll improvise. So what can we say about adopt an immutable application approach?
So immutable application is a phrase I've coined, actually. Well, I think I have. I've not seen it anyway. But
I love it.
This is actually more specifically to do with regression testing. So I've had problems in the past where you run things like integration testing and so on an environment which is shared.
Yeah.
And you end up with runs that have happened previously that leave a polluted state behind in that shared environment, that when the next integration test runs, it fails.
Yeah, and the classic one of that is data, isn't it?
It's mostly to do with data, yeah. Although it can be like disruptive tests and so on, but
it's also to do with you're trying to run multiple tests, and someone can have deployed something and that's changed something else, and because you've got shared resources or whatever.
Exactly.
And so that environment has become mutable, and it's then become polluted, and so you don't get consistent results, and therefore you can't guarantee quality, and all sorts of bad things flow out of that over what is of what sounds like a relatively innocuous thing.
Exactly. It's those nasty little problems that occur that because it's non-deterministic, you end up with issues that can sometimes take you ages to try and figure out what's happened before you realise that actually, the previous test polluted the database or whatever.
And that's actually a really kind of sorry to jump in, but theory of software testing, making a test deterministic is actually, if you're looking at how to do tests, make them deterministic. That's an utterly important thing, because if a test is not deterministic, it's not a test.
Yeah, you can get well. That's true. You take a high-level view of they must be deterministic. Of course, tests must be deterministic, but occasionally you do have tests, particularly in integration tests, where you have timing issues and so on, and sometimes those timing issues are somewhat out of your control, and occasionally you get tests that are what you would consider flaky, right?
Yeah.
Most of the time, but occasionally you get this really odd error that comes up, and
we've all done it, because we've all said the whole thing of you do this test run, 200 tests run, and test number 37 doesn't pass, and everyone says, "Oh, just run that one again; it'll be fine second time."
Exactly.
We all know that.
It's like, oh, brilliant, I've passed. So actually, there's an interesting approach that you can take, and I think Kubernetes take this in their test suite, that you can mark tests up. So we always used to do test categories in the past. So you do like unit and integration, smoke tests, acceptance tests, and so on, and you would categorize tests. But you can also like taint or set traits on tests. Yeah. So you could say a trait is that the test is slow. So it's not that it's broken, it just takes a long time. Or a test is flaky. For the situations where a test works most of the time, but occasionally there's a little timing issue in there. Maybe it's talking to some external resource that can cause timing issues. And so with traits like flaky, you could actually have a policy in that says, well, if it does fail, maybe I just retry it and actually make that part of the pipeline to retry a flaky test so that it doesn't break the pipeline. Somebody's got to manually go in and restart the pipeline because it's a flaky test. And also you can get to see what traits on tests that you have. So things like flaky might be something that actually, for now it's okay, but we should
be looking at that
on backlog, and we need to probably look at that at some point and make it a bit more deterministic than it is. Maybe there's an issue in the code that means we need to be a bit more resilient to maybe timing related issues or whatever. But
yeah, and because what starts to happen is people see the flaky test has failed and they say, oh, that's okay, that one always fails.
That one always fails,
and then what if it fails for a different reason? Yeah, it's like you just don't know.
Exactly, mate. So that's some things we can do. We use for Golang, we use Ginkgo that allows you to effectively you can filter tests when you run them. So as long as you've got a pattern that you can recognize in the test description, then you can effectively mark them up as categorize and taint the tests, which is quite nice.
Yeah. So the other thing is that like we keep on saying, we build everything on Kubernetes for a whole variety of reasons. But that also gives us a really good part of this story, doesn't it?
It does, and this sort of, the immutable application approach does rely on tools like Kubernetes being able to isolate workloads from each other. So if you were to say if you've got an environment, a shared environment where you're doing regression testing and you get this pollution that occurs, one way of solving it is to ensure that whenever a test runs, that it resets the state in the environment that is the state of the start of its tests. Yeah. It becomes more deterministic. But you end up having to put a lot of code in into your tests that make sure that the state is reset at the beginning of every test. You also then need to make sure that you can't really have tests running in parallel, talking to the same shared resources, because if they're running in parallel, you might reset the state, but if another test is running at the same time, well, you're back
then you suddenly wiped out the state for that test as well.
Exactly that. So you then have to serialize your tests, which you then really get no throughput, depending on the size of your development team, of course, and how quickly they're pushing through changes into the environment, and a particular changes against the same repository. However,
but immutable application solves this problem.
Yeah, exactly. So, and the basic idea behind this is that you take advantage of the ability to isolate workloads in Kubernetes using Helm, where we deploy an entire application isolated into its own namespace, in effect. And so when the test runs, part of running the test is deploy the application. You know that when the application is deployed, it's in its vanilla state. Run your tests, and then at the end, collect the test results, and then at the end of it, destroy
you tear it down.
Destroy the instance of that application. And what it means is, again, you have to, if you're going to take this approach, you have to think that I could have multiple instances of my application running on a single cluster. So you've got to be able to make sure that that works. But by having that isolation and having these applications be deployed, test run, destroyed continually means that you can also run tests in parallel. It becomes much more deterministic. You can also run all your tests in parallel, so all your regression tests can be run in parallel.
Yeah, which means that because one of the things that is a big problem with DevOps, and again we've been on projects where this has happened, where if you've got a busy team, and this often happens in kind of a particularly in if you're we talked about this in process stuff in the past, that you shouldn't really be having massive stabilization periods, but if you're having but if you're working towards a go live, for example, and you're making a lot of small tweaks and you're putting small features in because you're trying to just do all the finishing touches to make your application, you end up with a lot of commits going through. And if you can't parallelize your testing, then you can soon end up with a backlog on your release pipeline, simply because that test cycle just can't keep up with the rates of commits. And parallelizing means that you don't get that same backlog, because each of them takes on a life cycle of their own without having to back up behind the one in front.
Exactly, and then there's no cost pollution. So, I mean, the sort of crude forms of parallelization that we've had in the past is where you have completely separate test environments. So, you're talking about the much more sort of bigger stabilization phases that we've been involved in before.
But we've been on projects where, we've in the past, where there's been ridiculous numbers of environments.
Exactly.
With humongous attendance, and the attendant costs of those are just have been it's been literally like 40 environments, each of which has got 30 servers in it. I mean, it's and you sort of multiply that out, and even if you virtualize it, it's still ridiculous.
It is, and imagine though that those environments exist even when you're not working.
Yeah.
So, so the costs just keep going on. Whereas if you're running on a cluster with like auto scaling groups, then when you're at your busiest, the cluster's scaled out, handling. The applications are still dense on there, so you're still getting bang for buck in terms of usage of those machines in that cluster. But when people go home and the cluster's not being used, it can scale back and reduce costs. So you get a much more cost-effective solution. Having services like Kubernetes running your isolated applications, but on the cloud where you have the ability to auto scale, just makes it, you have the density of utilization by running your application in containers on a cluster. But also you get to save costs when you're not really using it. So you could say, what's not to like, really?
Absolutely.
Everyone wants to save costs, right? And it's a natural place to save costs, particularly based on working cycles of when people are in and when they're not. So why not try and save costs when people are not working?
So. Yeah. So not only have we solved your application quality issues, but we've also told you how to massively reduce your test costs for large projects. So it's the amount of value everyone gets out of this podcast is huge, isn't it? In fact, if you want to, if you found this has reduced your testing costs and you want to make a donation, then get in touch. We'll happily we'll happily accommodate you. I know that's a bit hopeful. The best I'm really expecting for is a thumbs up. But at least do that. Or a subscribe. Like and subscribe. Thanks, everyone. That really helps, because it at least lets us know that people are out there. So principle number 6, immutable application, and we've gone, great stuff. Principle number 7 is actually back onto the infrastructure, and that is that each, so principle number 7 is that each infrastructure environment gets its own repo.
Yeah, well, actually, we did touch on this before, didn't we? When we were talking about principle 2, Git is the source.
The Git is the source of truth, but this is really just sort of fleshing out the fact that so principles 7 and 8 are really just fleshing out the fact that Git is the source of truth, but you can use it and abuse it. Now, I know of very large household name companies that adopt a microservices approach and have tons and tons and tons of microservices, but they have one repo because they like to trigger everything off one build. So you can do that. We don't recommend it. We've taken the approach to say, actually, separate out each separate out well, certainly this principle is about environments and infrastructure, so each environment gets its own repo, and there's a lot of good reasons for that. So the first one, and okay, this was in the last episode, but security. So maybe we'll start with that one.
Absolutely. So production environment is something that you don't. It's a sensitive environment, right? So you don't want anybody going in there and making changes that could break it. So
and changes to production should be, particularly from an infrastructure point of view, they should be fairly rare. Application changes might be frequent, but infrastructure changes are relatively rare.
I would say so. Yeah. I mean, obviously during the development phase, if you're doing a new release, there might be infrastructure changes related to that release. Obviously, if you're building a brand new application, there will be
that's evolving all the
time. Changes. Yeah, exactly. It will be evolving.
But as your app matures, from an infrastructure point of view, then that tends to mature, and so.
Absolutely. So the only thing that might change, not even on an often basis, but you might decide to change the EC2. So if you're on Amazon, so if you're on Amazon, if you're on Azure, it'll be different. But if you want to change the size of your machine, if you want to tweak
operating system.
Exactly. If you wanted to change operating system, of course, yeah. But if you're
change the version of it,
more, which would take the immutable infrastructure approach, where you would deploy new images and then migrate the workload over to those new images for the new operating system or the new version of the operating system. Whereas with this, it's if you were going, I'm running on, I don't know, a T2 machine, but actually I really need to be running on a T3, then you would be making changes to the cluster templates in effect and deploying those, which is classed as infrastructure. There would be the sort of smaller changes, like maybe you're changing the properties on the auto scaling group. Where you allowed the group to scale to 10 nodes. Maybe now you really need it to be able to scale to 15 nodes. And so you're making the sort of the tweaks that you might make on a more often basis than maybe adding brand new services into the environment that you're going to utilize. That might upgrade.
Yeah, and like you say, you might change those quite frequently. So we were just talking about immutable applications, and if you ramp up your dev team, you might find that your sort of integration test environment needs to you might be tweaking auto scaling that all the time, whereas actually because of the dev workloads are flexing, whereas production you're going to be looking at that not with what your dev workload is, but what your production workload is, and so we want to be able to just keep it's just keeping control of those separately, but having one source of truth.
Exactly that, and obviously each infrastructure environment, whilst they're all running your application, they're all doing so with ever so slightly different shapes. Production is going to be fully scaled out. It's going to probably run across availability zones. You're probably going to have different subnets for different node groups, like DMZs, and isolating your data tier off, with no external network access, that sort of thing. Whereas you might not have the same level of scale out and cross availability zone shape to an integration testing environment. Your staging environment might look like production, but maybe not quite so scaled out. Then, if you create performance environments, and you want to try different shapes in order to test different things. So, if you're doing scalability testing or exception testing, or just basic performance testing, you probably want to tweak things and try different types of environment out to see what works. And so every environment sort of ends up with a different shape. So the way that we do it is the sort of the high level name of the environment. So integration testing, stage, production, performance, development. These are all what we would call different environments that exist in different Git repositories.
Yeah, so that's the repo level.
That's the repo level.
Yeah. Then
you might actually have, so this really actually comes down to probably more so with performance, where one deployed environment you might want to run with a smaller set of nodes, and another performance environment you might want to run with more nodes, or slightly different nodes, or maybe different disks attached to the nodes, and so on. We would still treat that as the same Git repository, but what we do is we actually use branching to represent the different instances of those environments. And then we have built a whole process around the release of changes through these instance branches. What it also means is we can protect those instance branches with, so we use GitHub. You can create a code owners file, which defines who's allowed to approve changes made to code in that branch. So all of our we have instance branches that represent deployed infrastructure environments, and then we make sure that we have a code owners file associated with each one, which means that only certain people can approve infrastructure changes. And then we tie into GitHub releases. So in order to actually deploy those changes to an environment, you have to actually produce a release in GitHub, and then we key off our hosted CI service based on the GitHub release, rather than say a merge to master or anything like that, or even a merge to the instance branch. So we do it through releases. So you have to actually go through the explicit process of releasing in order to actually push those changes out to an environment. So we have the sort of like the macro environment, dev, test, stage, performance, production, as different Git repositories, and then we use different branches in Git, which we call instance branches, that we protect, and we use them to represent deployed instances. And that works really well. It works very well indeed.
So one sort of thing on this that is probably worth pointing out, and it does happen with other teams as well, is that particularly data services, we kind of know about tin and like and our equivalent, which is your Kubernetes cluster. I mean, that's obviously infrastructure, which falls into this thing, but it's like and then when you come to your database type of thing, because most most of us, a lot of apps have ultimately have database services or other back-end services that use data, such as queuing services, event hubs, that sort of thing. It's like, do they fall as part of the application, or are they part of the infrastructure?
That's an interesting question, and the answer is it depends. So we have a bunch of what we would call infrastructure shared services that run on the cluster in pods.
Yeah.
So and you're right, they tend to be mostly around stateful workloads. So Kafka, Scylla, Hopefully pronounce that right again.
Just think Cilla Black.
Cilla Black, yes. We use Arango. So these are all stateful workloads. But they're all what we would consider shared infrastructure services. So the application, or many different application containers can take advantage of those shared infrastructure services. Now, there's the actual application itself. So Arango, as an application, runs on the cluster.
Yeah.
But within Arango, you have databases.
Yeah. And so the database forms part of the app.
The database forms part of the app.
But the underlying Arango service forms part of the infrastructure.
It does, yeah.
And same with Kafka, that you can, the topic is part of the app.
Yes, exactly that.
A Kafka installation is part of the infrastructure.
Exactly that. That's the approach we take. And so for example, we would use for an application container. So taking the microservice approach, where a microservice would have ownership of its data. So let's say product catalog. So a catalog service. The catalog service would have ownership of the product catalog database. And so when that container starts for the very first time on a cluster, within Kubernetes, you can also have the concept of init containers, which effectively allow you to pre-run a different container before you run the actual application container. So in the init container, what we can do is say, oh, we're starting for the first time. Does my database exist?
Yeah, and we covered a lot of this in our, if you want to go back to listen to the fundamentals of Kubernetes episode, we talked a lot about this. But do carry on just to quickly recap on this, because we.
So long ago, I've forgotten.
Yeah. We talked about init containers, sidecars,
so
a whole lot.
So anyway, back to init containers. So we take the approach of use the init container to deploy the database and the database schema. So prepare the shared infrastructure service, in effect, for the application. It means when the application runs, it's always going to find its database because we pre-prepared it. If the init container runs because I don't know, let's just say the pod shut down and it was restarted, and then the init container runs, it's going to find its database and go, well, there's nothing for me to do. But what you can also do with the init containers is then think about, well, potentially, how do I do upgrades? Because your upgrades are going to be one-off. Maybe you've got to change the schema. Maybe you've got to add some more definitions into your database. You can potentially do that as part of an init container. So it's that's generally the approach we take. So the underlying service is what we would consider part of the infrastructure, even though it's running as a pod on Kubernetes, a pod and set of services on Kubernetes. But the application specific item, like a database or a topic, is actually deployed as part of the application itself. So we sort of separate the two. Now, naturally, obviously, with shared infrastructure services, that you do get new versions, you get new releases. So how do you deal with that? And that has to be on a case-by-case basis. Now, generally speaking, if you run a stateful set in Kubernetes, then you can upgrade in a rolling manner.
Yeah.
So it'll upgrade effectively one replica of a pod every time in order. So it would upgrade one replica first, and if that's good, it would then upgrade the next one. If that's good, then it would upgrade the next one, and if that fails, then it rolls back.
Yeah,
so
and this is really, this is really important stuff. So for example, if you've got something like you mentioned Scylla before, or the much more bloatware-y version of it, Cassandra, that people may have heard of. that because that distributes data across multiple nodes, when you're putting a new version in, a new node in of that, you've got to allow time for the Scylla or the Cassandra service to actually reallocate shards onto the new nodes before you can then start taking other ones out. So it is a case by case basis, and but you have whilst a lot of these technologies can cope with machines going, they can't cope with all of them going
No.
at the same time. So we have to we have to know what we're doing and manage that in the most appropriate way.
And each one's different. I mean, there's a move towards, in Kubernetes world, there's a move towards using operators as a way of managing the life cycle of an application. And not every, what we would say is a shared infrastructure service, not every shared infrastructure service has an operator. So we've got, like, Arango has an operator, Prometheus has an operator, Kafka now has an operator. But not everyone does, so everyone has to be treated slightly differently when it comes to upgrades. And generally speaking, upgrades are new versions of the software. So if there's a new container image with a new version of, say, Kafka, how does that get deployed to the environment such that it doesn't disrupt the running?
Because that's got to be part of the same group and start to participate in the workload.
Exactly, mate. And hence why we tend to, when it comes to stateful services, we tend to try and pick technologies that work well in a cluster. So they run on consensus network, they have replicas, which then allow you to do a gradual rollout of a new version of a replica, of the service, rather than the sort of traditional approach of take the system down, do the upgrade, and then
tell all your users that services are unavailable between midnight and 3 a.m.
Yeah,
like, oh, God.
Exactly. And
some bugger's got to be in doing the.
As I say, we're lucky. We get to choose a lot of these newer technologies and newer approaches.
Whereas everyone else has got to shell out on Domino's at 3 a.m.
Yeah.
And again, we've all been there. Cool. Okay. So principle 7, each infrastructure gets its own Git repo and all things that flow from that. Principle 8 is the kind of the application equivalent. So principle 8 is each application microservices and shared library gets its own Git repo.
Yeah, and I think this is it's the same. It's you can think of it as being the same thing, right?
But so you can also think of it as in terms of principles of microservices. Principle number 1: each microservice is independently deployable.
Exactly. So, and I think
so back to that whole thing where you may think you're saving time by having all your microservices in the same repo. What actually comes from that is that it's then harder to make them independently deployable and that sort of thing, because the triggers tend to be at a branch level.
Yeah, I think it becomes a lot more difficult to manage if it's all in the same repository. And you're absolutely right about the principles. They should be independently deployable.
Yeah.
The easiest unit of deployment is at the repo level, because most things tend to work at a repo level. Hosted CI services tend to work at a Git repository level.
Yeah.
So it makes sense to have all of your microservices in separate Git repositories. I mean, you get the benefit of security isolation. So we talked about in the last episode about security isolation, and particularly for repositories that are quite sensitive, so like security code. So having them separated out into their own repositories is a good thing. By the same token, it's not just microservices. We also separate out libraries as well into their own repositories. But naturally, there is a cost associated with that. The more repositories that you have, the more artifacts you're going to have to support DevOps, because each repository has to go through pretty much the same process. Each application repository needs to go through the same process in terms of going through the sort of continuous integration, continuous delivery process.
So whilst that sounds, so the downside is you end up with a large number of repos and a large number of, and each of those got their own DevOps thing. But typically speaking, that is quite cookie cutter, isn't it? I mean, it's not as if you start from scratch and say, oh, I've got to rewrite a whole DevOps process for this new repo. It's pretty much, if you've got an API that's got some data behind it and that sort of thing, pretty much it's a cookie cutter approach where you take that same thing.
Pretty much, yeah. I mean, every the core of deploying every application microservice is going to be the same, roughly speaking. There are going to be the odd difference here and there, depending on what resources does it rely on. Like that, we use Helm for packaging Kubernetes resources and deploying them in a chart and deploying them as a release into a Kubernetes environment. So the Helm charts obviously are going to be different between each microservice. But again, it's going to be differences specific to the application itself. But you still take almost a cookie cutter approach to building the Helm chart. Every microservice will have a config map representing its config that can then be changed per environment, because every environment is going to have different addresses of external resources and so on. So this is how we do per environment configuration. So isolate the configuration off in its own config map, and then make sure that that's updated when you build the Helm chart as part of your sort of continuous integration process. So yeah, there's a fair old chunk of things that you need to do to bootstrap a repository. So we just make sure that when we create a task on the backlog and we estimate it, and it's create this new repository for this new service, then we just allow for the fact that that's going to take to be generous, it's going to take a couple of days.
Yeah.
The reality is it's not, because it is cookie cutter, but you want to make sure that at the end of it, you've got a skeleton service deploying through the different environments, running all the quality tests. Even if no tests exist at this point, you still have the mechanisms in place for ensuring that service goes through the quality process.
Yeah, and okay, it takes a bit of time at the start of making that microservice, but ultimately, like everything else that we've talked about at DevOps, DevOps is an investment that you get payback later.
Yes.
And so just like this, when we're sort of saying that each in principle, each microservice gets its own repo, and okay, that takes a little bit of investment when you set it up. However, the fact that once you've done that, and each microservice effectively is independent from the others and has its own life cycle, the paybacks you get in having decoupled that, pay off later.
They do, absolutely. It's just a necessary part of building new services. It's an extended cost in effect.
Yeah, and the same thing. I mean, that applies to all DevOps. So all the principles we've got, and DevOps as a whole, it's an investment. So you put the hard work in up front, and you get the payback later.
Exactly.
And the bigger your project, and the longer it runs for, the more you get that. The more bountiful that payoff is.
Exactly. Now we talked about, we mostly been talking about microservices here, but we also have the same approach for shared libraries. We have them separated out into Git repositories. These are a little bit more lightweight when it comes to the sort of DevOps process. Yes, they need to go through a quality pipeline that checks, that runs unit tests and integration tests if those libraries are calling external resources. but you don't deploy a library to different environments as a running service.
Yeah, you put it in some kind of artifact repository.
Exactly. So they get made available to, those shared libraries get made available to your microservices to pull down. So as long as you've got some way of packaging and vendoring that library, then each microservice on its own development cycle can pull in whatever version it needs. So for example, we have shared libraries like, login and metrics and so on. And you might make a change to logging. It's version 1. You make some upgrades to it, and it's now version 2. You don't have to pull that version 2 into every microservice. You can release version 2. It's a bit like, open source. When you release a new version of the library, not everybody has to upgrade. What you can do is form that part of the backlog. So make a decision that on the next version of your microservice, that actually you're going to also upgrade the versions of the dependent libraries.
And this is probably a good time to point out that pin your versions.
Yes, pin your versions.
Don't just say take the latest one. Otherwise, it's like saying take my trousers down. It's not a good thing.
Yeah, it's like working on quicksand. It's a constantly move. If you, depending on how many dependencies you have, and if you're working in the sort of JavaScript and NPM world, you can have so many dependencies that if you allow them to, almost auto upgrade, then it's constantly shifting sands under your feet, and you can't get any determinism out of it. You don't know whether the change you're making to your application is a thing that you've introduced as a bug, or whether it's a dependent library that's changed version and changed behavior.
Yeah, and it's like the whole thing, change one thing at a time.
Exactly, change one thing at a time. And so we would treat changing dependent versions of libraries as a task in its own right, because then at least you can isolate the fact that if your application was working, your upgrade libraries now no longer works, it's one of those libraries that's the cause of the problem. So again, it's a little bit of a discipline, development discipline approach, but it's an important one. So pin versions and then treat version upgrades of shared libraries as a development task in its own right.
Yeah, absolutely. And so that kind of nicely rounds off Principle 8. Each application microservices and the shared library gets its own Git repo, which doesn't roll off the tongue very easily, but
no.
but we've got that covered. Principle number 9, and this actually follows quite closely. So for those of you who are lapping up principle number 3, no sensitive data or values are stored in Git. Principle number 9 is another part of that similar one, which is application configuration is environment specific. And so part of application configuration or part of environment configuration is security keys. But there's also all that other stuff that goes in there, such as connection strings, IP addresses, URLs, how many of this do I have? What's my limit on there's a whole load of there's a whole load of configuration that changes per environment, and actually managing this isn't easy.
No. It's not super easy, but there's obviously approaches you can take. I mean, it's fun. It's a funny one actually, because you think it's pretty obvious, right? But
yeah,
we all know someone who's hard coded the address of the service in their code and deployed it, right?
Yeah, and we all know everyone that's put a database connection string. They pointed to localhost and put the SA password in. And, we all know that's and don't. I'll just say that again. Don't.
Or even worse, points to as the name of the development machine hard coded in the URL, and works on my machine. And then when you deploy it in another environment, it's like it's no longer able to connect.
Yeah.
So
we will point out if you're doing these sort of things, and obviously we're not talking about you, we're talking about the others. But if you do this sort of thing, you're a muppet. Right? That's just there's no other. Just sit down, have a long think, and decide whether this career is the right thing for you. Because if you're doing that sort of thing, just take a long, hard look at yourself.
Occasionally, these things try to sneak through, but that's why we have code reviews, right?
Yeah.
So
and it's why we have principles.
And why we have principles, yeah. But yeah, it's see with Kubernetes actually makes it relatively a bit easier. So first things first, you've got to get in the mindset that configuration does belong in a configuration file of some sort. So don't when you do code reviews, it's a case of always keeping an eye out for properties that could well be changed. That could well be changed based on the environment that it runs in. So make sure that those are externalized in a config file.
Who's responsible for that?
Well, to be honest, really the developer. I mean, they should have a good enough sense for when they're writing the code that actually, this looks like it could, might be a useful thing to change in an environment. The classic ones that actually get hard coded are things like timeout values, where you're connecting to an endpoint, and you hard code the timeout to be 60 seconds. Well, you'd think actually 60 seconds is plenty of time, but maybe in an environment it needs to be higher, or maybe it needs to be lower.
Yeah.
But you hard code it, you got no one's got any chance of being able to tweak that setting in a particular environment. And a lot of these things are really important when you're performance testing, because you want to be able to tweak these settings in order to be able to affect the behavior of the application, right? So
what's starting to flush out?
It comes to the developer. The developer's got to think, when they're developing, don't just bang out the code. It's thinking, actually, this really does need to be in a separate config file, and I'm going to put the effort in to make sure that is put into the config file. It's ready on service startup, and then it's made available to the point in the code where I need to use it.
Yeah, and that's a part of being a technical lead and a mentor to developers and team lead in software dev and that sort of thing, is this whole thing of actually instilling that discipline into people and making sure that you keep the message consistent and that sort of thing. The other thing that I noticed started to come out of what you're saying is that there are certain categories of items that start to appear. So one of them, like you said, is that anything related to performance, which can be timeouts, it can be queue depths, numbers of things that change depending on workload. So that's so those ones should always be a kind of a category that you're kind of looking for. Another category, and we've already mentioned this with things like URLs. Let's say you're going to call another microservice, it's going to have a URL. So where stuff is, where my database is, where these other services I'm going to call are, where my logging service is, those type of things as well tend to be. So there's performance related stuff, the numbers and counts and times and that sort of thing. There's where stuff is, and another one that is I'm struggling to think of a category name for this, but logging level is a classic one. Different.
That is a classic one, actually, isn't it? Yeah.
Different environments have a different logging level. Make that an environment specific, and you will always be much happier. But I'm not. So there's that kind of. I'm trying to think of a category that logging level would fit into, but logging level is such an obvious one. It's just like, logging.
Yeah, it's diagnostics, right? So you might want to switch on metrics in certain environments, but maybe not in others.
Yeah.
Or certain classes of metrics in some environments and not others. So this sort of all comes under the sort of diagnostics banner. But it is important to make sure that that you say that the discipline is there to think about is it sensible for this environment, for this property to be environment specific, to be able to be changed per environment, and if it is, even if that property ends up being the same value in every environment, it doesn't matter. You should externalize it. And it's also then the responsibility of the code reviewer to pick up on places in the code where that hasn't happened. I mean, it is depending on how it works in your code base, how you externalize config in your code base. It isn't as easy as hard coding. There is and it's a discipline thing, but there's a little cost associated with going through the process of externalizing it and making it changeable in an environment, and then pulling that in on service startup and making that available in the application somewhere that the code you're running can actually get that value. So there is a cost, but it's a good cost again. Discipline does instill some cost, generally speaking.
And when you get to the point where you say, "Oh, I just need to change this value," when you've got that already pulled out, then suddenly it's really cheap to do it, rather than really expensive. So,
exactly. Yeah.
And it's just good practice. Are there any other particular points on application configuration, environment specific properties that we need to point out, such as how particular tips and tricks or particular pitfalls?
I guess not. I mean, it's each DevOps environment, language of choice, the way the runtime environment for the application, everything's different.
Yeah.
So how you do config is probably going to be different across different technologies. But I mean, generally speaking, the way you externalize to a config file, I think that's fairly well established as a practice. But then it's how do I change that config file per environment? And that's going to be part of your DevOps process, and it's going to be different depending on how that config file is made available.
But the fact is, you have to each of those configurations per environment is in itself code, and is in itself reviewable, and is in itself versioned, and and all that stuff, so that we've got a proper control on it, and we can see what it is.
Exactly. And so, as I say, because we use Kubernetes, we can package up the application config file in a Helm chart, but within a config map Kubernetes resource, or even a secret in Kubernetes that effectively it's a resource that allows you to load the config file as a volume inside a container. So it externalizes that config even outside of the application container, which is great because it means that we can, as part of our DevOps process, we can make sure that that config map is changed per environment. But it also gives us the ability to make changes to that config map outside of the app container whilst the app is running. So we could.
So if we want to change the verbosity of our logging,
then we can do that. Yeah. So we can either do that doing in-place upgrades in Kubernetes. You do like patches and stuff. Although we're going back to one of our earlier principles of should we be making changes to the sort of in-place changes to an application while it's running in the environment, or should those changes be originate from Git with the source of truth and going through the DevOps process? Now we can do that with config maps as well, because we make a change to the config map, repackage it in a new version of Helm chart, redeploy the new Helm chart, and then change the config map that way. So we've got there's obviously options that we can have there, but by externalizing it out, not just of the application binary, but also outside of the application container, we open up a whole load of possibilities for how we can manage that environment config.
Yeah. Cool. So that is principle number 9. Application configuration is environment specific, and hence we have a separate one for each environment that we can inspect and version and deploy and all that sort of thing. Principle number 9 is closed off, and we move rapidly on to principle number 10. And the last and very much not least, because one of the things that we've been talking about with, we spend a lot of time building microservices architectures in Kubernetes, and it's fantastic. You can deploy a new version really quickly, all automated. It rolls out, automated release pipeline, and then there are potential to, so principle number 10 is the protection against the car crash, which is I've deployed something that is not backwardly compatible. So principle number 10 is application changes must be backwards compatible, because if they are not, then you are coupling things together, basically.
Yeah, sort of, I guess. This is potential to be a really big subject.
Yeah.
We've spent many years, decades even, building integration solutions. So working on the sort of contract first approach to building systems, where you define the contract for how systems are going to talk to each other. We've gone through all the various different eras of ESBs and SOAs and microservices now, and anything where services talk to each other, but they need to be able to talk to each other based on a known contract.
Yeah.
Generally speaking, the principles of making sure that changes to contracts are backwards comparable is pretty much instilled in us, but it doesn't actually, it's not necessarily always the case with everybody. If you haven't gone through that experience before, then this is an area that can actually bring quite a few challenges, being backwards compatible. But it's really, really important because microservices are independently deployable, and given the fact that they're micro, chances are your application's decomposed into lots of different microservices. You're not necessarily going to go through that whole sort of big bang monolithic app upgrade where you take the system down, deploy all your new application components, and then bring the system back up again.
In fact, we would specifically advise against that.
Exactly, and now we're moving towards this world where we can do these small upgrades, isolated upgrades, without affecting the entire application, so the application can continue to run with no loss of service, which is where we really want to get to. You then have to really consider backwards compatibility, and part of that is to ensure that whenever you deploy a new version, that your contract hasn't changed, or if it has changed, that you've only added to the contract. So older clients can still continue to function without seeing these new changes, these new additions that have been made to the contract.
Yeah, and that can throw in some, some issues. So for example, typically now with APIs we're using JSON and we're serializing JSON, but when you deserialize, it's if you have new fields, you have to make sure that you're not being too strict on that, so that the old app might should be able to just ignore the fields you've added rather than go splat. So there is
there is actually, and that becomes a bit more sort of forwards compatibility, where you have there's a period of time during the upgrade where you could have old app talking to new app talking to old app. You'd have a combination of, and you need to be able to make sure that both sides are able to cope with changes in or additions in a contract. in exactly the way that you're describing. So if there's additional data in the contract that you weren't expecting, it's like, well, I don't need it because actually I'm still able to function on the reduced set data because that's on the previous version. It becomes a real problem though, where if you change stuff, so let's say you change the name of a field, which is quite important, and then suddenly your old applications can no longer function because the field that they relied on doesn't exist anymore. You've renamed it. Well, it probably does exist, but you've just gone and renamed it. So you've got no chance. So you shouldn't rename. And obviously delete is a big problem too. Again, for the same reason, it might be relying on that field, and all of a sudden, new version, you've gone and deleted that, or you've gone and completely changed the structure of the message, format that the service is relying on, and so therefore it sees it as either a delete or a change. So that's when we talk about backwards compatibility.
Yeah, and there are some strategies we can do for that. So, for example, that's where you can version your routes on an API, so that an old version of the route might still exist, but a new version might have you've got if you have sometimes you have to change the structure of your data. You thought you had a one-to-one, then you've got a one-to-many. You've got to change it, but you can actually effectively keep your old route there, but have a translation layer onto your new stuff, and it gets those are exceptions that you should you should be treading with caution if you're going down those routes, rather than changing and deleting with abandon.
Yeah, and the contracts exist at different levels, right? So we have service contracts at microservice level, but you might have code contracts with shared libraries. And so you sort of almost take that semantic versioning approach where if it's a patch release, it's got to be backwards compatible. But if you're, say, rolling out a major release, then you might actually want to consider that as just a different application. A different service.
Yeah.
That might just be a different microservice, and then therefore you need, new clients to take advantage of new versions.
And then you're back to treating that like you had a different library, and you have a task to change this microservice over to a different library. If you've got a client that's calling a microservice, you might then have a task to change that client over to the new microservice.
Exactly, and that's what also comes down to your putting the version in the root, because you would, if you were making patch releases, then you probably wouldn't change the root because they would be backwards compatible. The client would never know that you've patched the service. But if the contract between the client and the service changes significantly, then you might add a new routing, so a new version route. In which case, then the client, will need to call a completely new URL and therefore treat it as a new, as a brand new service. So absolutely right. Version handling, could be at the root level, could be, within the message format itself. So the message, you might be having messages going back and forth over a WebSocket. That message format, you could have a header in there that has a version number, and then the code literally just interrogates. As long as the header doesn't change, then you look at the version, you look at the message type, and go, right, I'll pick the appropriate handler that handles that type of message with that version.
And funnily enough, I mean, going back way back, I mean, we used to use a pattern created by a certain Mr. Paul Brown about having XML envelopes.
Oh yes, yeah.
With a consistent header.
I don't think I created it, but yeah,
that had an opaque body, and then someone had created a library to do all this, and we used to do it all the time. Just as and now they've got the similar thing, but on things like sockets and on and on event hubs and all that sort of thing, that you can, if you have consistent header information, things can scan for the messages that are relevant and just ignore things that aren't.
Absolutely. And so you can have multi-version handling baked directly into the application just through set of different handlers.
And that again is just, yeah, there's an experience thing that comes in there, isn't it? That you have to have been bitten by that before to think next time I'll bake that, I'll put that in the design. And then, and again, it's a little bit more work up front, but then
Yes.
you save the pain later on. So there's a certain amount of experience and kind of knowing how to avoid the bear traps that goes into that.
Exactly, and yeah, it's what it's exactly that. It's the experience of having been in those situations before. But when you have, if you're sending messages over on, say, a Kafka topic, straight away you're thinking, right, I need to think about versioning because this could change, and if it does change, I need my my publishers and consumers to be able to handle the different versions. So so it's definitely an important principle. Now, obviously, if things fail, if you upgrade, things do fail, then you need to rely on the sort of upgrade strategies that we talked about, like blue, green, and so on, in order to be able to then switch back and then keep the service running and then figure out what happened, why did this not work. So so it's really important that when you are deploying microservices that you have that you're thinking about not just upgrade, but you're thinking about how do you do rollback in the event of failure, because you might think you're compatible, but there could be something that you just didn't expect that happened and it didn't work. There's also there's another approach some people take, which is the whole fix forward. So if you don't run a blue green where you run versions side by side, but you do an in-place upgrade, then how do you roll back? Well, you don't. So you take the approach of, well, I need to fix forward. So you get a fix, you get a patch out, and then you push that through the pipeline and get that out into the environment as quickly as possible. So you're fixing forward. But obviously, if that happens, then you could have some downtime for traffic that runs through that particular.
And that depends on the, you've got to look at what is the business you're in, and is fixing forward appropriate or even allowable.
Yeah.
So if you're running a social media site, you probably move fast, fix forward, because lives will not be lost. Someone's photo might be, but lives will not be lost. Whereas the more mission critical things are, then that tends to become less acceptable. You don't kind of run an air traffic control system like that.
Exactly, and it's but also like more public facing. Maybe there's a reputational thing. Yeah. So you might have public facing services that reputationally you want to make sure that you can always roll back whenever you do upgrades if they fail. But there might be internal services that are also part of the application, but are not publicly exposed. That you might think, well, actually, you know what? If the upgrade doesn't work on that particular internal service, it's not the end of the world.
Yeah.
No one's going to see it. Obviously there might be some particular aspect of the internal system that's not working, but you can fix forward on that. Collecting metrics, for example, maybe. You might decide that if suddenly you're dropping metrics because you can't store them, maybe you fix forward, because it's not the end of the world if you don't collect those metrics.
Yeah. So if I end up with a gap in my recordings of disk utilization and CPU time or something like that, then that might be okay. It's one of those things we don't want to do it, but ultimately we've got a continuation service.
Yeah, exactly. I sort of, we talk about blue, green, and canary and so on. And I'd read somewhere that the whole fix forward, so in place upgrades, is actually called the Highlander strategy, which I absolutely love because there can be only one, right? So that's the idea that you can't have two versions. There can only be one version on the cover. So you do that in place upgrade, and it's called the Highlander strategy, which which is an absolutely fantastic film.
It is,
if you grew up in the 80s,
if you grew up,
if you watch it now, it's
like in the 80s, and you can call your releases the quickening. Or...
Yeah, indeed, yeah. If you watch it now, it's actually it's still a brilliant film, but it's
slightly cheesy.
It goes age a little bit. Fantastic.
Cool. So we've gone over the principles now. We've got through 1 to 10 or 5 to 10 as it is in this one. Is there anything on, certainly in terms of the tools technologies side, that we could do with talking about, or process side, or should we save that for another thing? I think DevOps Stack's probably it's probably an episode in its own, isn't it?
Possibly, yeah. I mean, our DevOps stack, I guess, what we use in the glue.
Yeah.
We use quite a lot of different tools to support the process. We've actually talked over some of them in not just this podcast, but in previous ones.
Yeah.
But maybe it might be quite a nice subject for another time to run through exactly what toolset we're using, and to be clear about when we're using it, why we're using it.
I think we should do that. I think that would be a good thing to do. And given the fact that we've provided enough value in this one, I think we can probably round up this episode there. So we've covered off, all in all, the principles 5 to 10. No, sorry, principles 6 to 10, as this one are. So principle number 6 was adopt an immutable application approach. Principle number 7 was each environment gets its own Git repo. Principle number 8 is each application microservice and the shared library gets its own Git repo. Principle number 9 is application config is environment specific. And principle number 10 is, there be dragons. Application changes must be backwards compatible and potentially forwards compatible. Yep. And all the stuff that flows out of that. And and that's a big subject with tread carefully written all over it. So, closing off the episode, thanks a lot, Paul, for your amazing insights, and I'm sure all our hundreds, thank you everyone, all our hundreds of listeners are very grateful to you for sharing your insights on all this stuff and your experience. We do this so that people don't have to go and learn this from scratch. They can learn this from people that have already taken the suffering. And so part of taking the toil out is taking the mental toil out and learning from others. I have seen further because I was standing on the shoulders of giants, and hopefully other people can stand on your giant shoulders and
just like I'm doing the same on other people, right?
And see further, yeah. And that's what software is all about.
It is. Yeah.
So thanks a lot for that. And so please tune in next week for another thrilling episode of 345 Tech Talks. I've been Andrew. I've got with me Paul, and we will see you next time.